So in this problem, we are simplifying a radical, and it's not a square root. Square roots are more normal, but look at this one. This is a cubed root, if you can see that teeny little 3 right there. And the cubed root is going to behave differently at the very end once I'm done with all the factor tree stuff. For the most part, my main job, building the factor tree, is the same as usual. And we'll just come back to that discussion of what to do with the cubed root part of this in a little bit. So let's work through the steps of building our factor tree. First, I'd like to point out that 120 is an even number. So I know it divides by 2. And I like doing this because this sort of math is very easy. I am really good at dividing things by 2. If you want, you can use a calculator, that's fine. And we get 60. Okay, so 60. And look at that. We got another even number. So I'm going to say, okay, this is great. I've got another even number. I'm going to build a factor tree branch right here. And I know 2 pulls out of 60. And what's left behind? Well, you just say 60 divided by 2. And in this case, that is equal to 30. So I put 30 right here. And you can keep on going like this, dividing by 2 as many times as you can without getting a decimal. In other words, looking for even numbers. But just for argument's sake, I'm going to say, well, okay, I'm tired of 2. Let's say we want to do something else. And I'm going to look for something else that divides into 30. Again, without decimals. So you could try 7, but 30 divided by 7 is not going to work so great. Let's just do 6. And if you say 30 divided by 6, what do you get? Well, you can use a calculator if you want, but you should get 5. So now I have 6 and 5. I'm not done yet because 6 is not a prime number. 2, 2, 5, those are all prime numbers, but 6 still has some work we can do with it. So I can divide 6 by 2 because it's an even number, and 6 divided by 2 makes 3. Now the factor tree is done. All that's left at the end of each branch is a prime number, and what I'm going to do is just make that really clear by circling all the primes. Oops, almost missed that one. Okay, so there we go. This is not my prettiest drawing ever, but you get the point. It's all prime numbers. I left out the 6 because that's not a prime. And watch how I'm going to rewrite this original cubed root function. Instead of the cubed root of 120, I'm going to say, well, that's really just the cubed root of 2 times another 2 times 3 times 5. Okay? And here's the part where we come back to, what about the cubed root? How is this different from a square root? Well, with square roots, you're looking for pairs. With cubed roots, you're looking for 3 of a kind. Okay, that's why we have to pay attention to that little 3 up there. So we pull out this group and we say, how do we rewrite it? Well, it's still a cubed root function. I've still got that 3 right there. But those 2's popped out. I've got a 2 sitting on the outside. This is 2 times the cubed root of something. And what's left? Well, there's a few numbers we can't do anything with, right? 3 and the 5, those multiply to 15. So this is going to be my answer right here. Because 3 and 5 are not 3 of a kind, they just stay there as stuck under the radical symbol.